Yeah, I'm Vincent. I'm working at Development Seed. Done a lot of things, but now we focus in dynamic tiling, and now we create map tiles from raster data. So just an overview. I'm going to talk about map tiles and how we create them from raster. And so a map tiles is just an image that we put on the map. Usually there are square images, 256 by 256 pixels. The format is usually PNG, JPEG, or WebP. And the map tiles, you saw them every time you go on a map. And so it's not playing. So anyway, should be a GIF. So every time you load the map, either on Google or on OpenStreetMap, you either see vector map tiles or raster map tiles. So, but I'm only going to focus on raster, and so those are everywhere. And there are two ways of creating those map tiles: either doing static tiling or dynamic tiling. And the static tiling is when you pre-generate all those tiles that you want to load on the map in advance. So what you will do is you take your raster data, your satellite images, and then you do a bunch of pre-processing on top of your data, and then cut this huge data set that you have into small pieces, into tiles. Then you put all those map tiles in the CDN or in the cloud infrastructures, and either put a proxy on top of it to serve the tiles, or just ask the client to access the tiles that are stored on the CDN. And so for this operation, you do pre-processing, you do you apply map processing on top of the data, reprojection, rescaling, and then you create billions of small tiles that you will put on the cloud. And which is pretty sad is sometimes some of those tiles will never be used. And because I'm really sad about that, I prefer dynamic tiling, because dynamic tiling, you only create the tiles that the user requests. So when you load the map using dynamic tiling, the web client will ask for tiles and ask the tiles to a proxy, so the server, which will do every step we just mentioned, but dynamically on request. So once you as a user or as a data provider, you just have to keep your raw data as much as raw as possible, and put it on the cloud somewhere, and just put a proxy that will do all the work on demand. And so then when you do static tilings as a data provider, you make choice. You decide how the data should look like for the users. So you make a lot of decisions for the users. But sometimes the users would want something in particular, and sometimes it means as a data provider, you will have to regenerate all those millions map tiles for specific users. And while with dynamic tiling, you give the power to the users. They can decide what they want, how they want the data to be represented. And then as a data provider, you do almost nothing. You just put the data on the cloud storage and put a proxy server on top. And so I'm going to describe the process of dynamic tiling. So what are the things that you can do and the user can do. So first, how it works. It's pretty simple. You have a server in the middle between your map client and your raster data, and the server will read the part of the data it needs to create the map tiles, and which means that when it reads the data, it also applies reprojection. It can also apply post-processing, so color rescaling and color correction, and a bunch of algorithms that the user wants. And then encode the array of data that it has as an image. And so it's pretty simple. Proxy, read the data, create the map tiles on demand. And so you can do dynamic tiling for run raster data, You can also have like multiple raster data that you want to mosaic together. So you can really open the possibilities of like what the user can do when you use dynamic tiling. And yeah, so yeah, should be a GIF showing like how a data load is not working. Not sure why. Anyway. So again, dynamic tiling can work with one cloud optimized dataset. It can work with multiple dataset, multiple bands. So if you have like multiple bands in one dataset, you can let the user choose which band it wants to display on demand. So again, should be a GIF showing like that you can select the band combination that you want to display, and the client will make new requests to the servers, and the server will combine new bands together and serve as map tiles. And so it works really well for one dataset. So when the user know which dataset he wants to display, but you can also go crazy and like do mosaicing on demand for multiple cloud optimized datasets. And so this was also an example where we dynamically are reading like a lot of files, like covering each tile. So on each tile request, the server will find what are the dataset that covers the tiles, and like mosaic and create the tiles from all those files together. And so when you think about that, it can also like open new possibilities for the users, like to choose which data goes on top of the other. Do you want to merge all the pixel values together? Do you want to take the highest values or whatever? You can like really start thinking about like all the possibilities that dynamic tiling offers to the users, like to really bring back power to the user to decide how the data should look like, and also like make the user think that mosaicing is not as simple as just putting all those images together. You have to make choice, and like sometimes the user wants to have those choice, like to put the oldest image on top or the newest. And so this is what kind of things that dynamic tiling offers. And again, also the projection is important. So you don't have to reproject the data as a data provider. You can just keep the data in a local projection it was acquired, and like the dynamic tiling tiler like will handle everything like from the raw data to the projection the user wants the data to be in. And so you have the input projection, and you also have the output projection. And this was just an example to show like that you can, with dynamic tiling, have your output tiles in Web Mercator or in other TMS grid. And again, you don't have to pre-generate all those tiles. So if you wanted to serve like 4 different TMS maps, TMS grid, you will have to generate like billions of small tiles that will maybe never be used. And so with dynamic tiling, you just like put a server in top of your data, and the map client will say, hey, I want this map tiles index in like this projection, and like the dynamic tiler like enables this kind of usage. And something important is like the data itself. Like when an image data that you see on the client, on the map client, is like a PNG or JPEG or WebP, there are byte data. So there are data rescaled between 0 and 255. But like when you do the acquisition, when you have like them values, for example, they don't go from 0 to 255. They go from minus 10,000 to plus 8,000 or whatever. And if you are working with mass data, it's even higher. But like it means that when you create those map tiles, you have to rescale the data to get like something that will be visible on the client. And so you have to rescale those data as bytes. But like how do you scale the data can be different. Like the user might want to see really specific features, like higher than certain values or whatever. So the data type that you have and how you make a visible version of it is also something important. And like as a data provider, if you have to make all those choices, like about what we talked before, like, and also about data type, like you make really a lot of choice. And like with dynamic tiling, you can let the user explore, let the user like decide and make all those choices, how the data should look like. And so that was just an example, like how to apply like a color map on top of your data dynamically, and let the user select like how the data should look like based on the raw data values. And same, that was another example of showing like that you can do band selection. So you can choose how the data should look like as simple RGB. So like in the visual representation, or like do other band combination, but you can also do band math. You can, like, for example, calculate NDVI on the fly, on demand, and again choose how the NDVI value should be represented, like what kind of color maps do you want to apply, and what kind of rescaling you want to apply to highlight some values. And so, yeah, just to summarize, dynamic tiling is all about like giving power to the user, so it can select bands, select the output projection, select the output format, because it don't have to be like JPEG or PNG. You can also have TIFF or like NumPy tile or whatever format you want, and that are supported by the tile server that you are using. And you can also apply band math and more complex processing. You can have a custom algorithm running on top of your map tiles of your servers that will also take auxiliary data on each tile demand. And yeah, so it really opens like the possibilities of what you can do with your raw data, and not just like pre-processing everything and thinking about what the user will want. Like in advance, you just like put the dynamic tiler on top of your data, and you let the user decide. And so for dynamic tiling, something which is important, it's how the data is stored, where it's stored, and like the data format itself. Like for dynamic tiling to work well, you have to have a cloud optimized data set. And a cloud optimized data set is a data set that can be accessed remotely by any server, but not just the access, like accessing the start of your file. You have to be able, the server has to be able to access like the middle of the file, or the end of the file, without loading the whole file. So a cloud optimized data set should have a header value, where there is an internal map of all the data. So the TiTiler can just read the first few bytes of your data set, and then know which binary range it has to read to create the tiles. So there are multiple cloud optimized data sets. So there is a cloud optimized GeoTIFF, there is the point cloud optimized now, and the ZAR could be considered as a cloud optimized data set because it's chunked in small pieces, and you can like easily find the binary that you need to create those map tiles. And so yeah, data is really important. And so the data format is important, and so either it's a cloud optimized GeoTIFF or ZAR, but there are also like things to consider. You have to choose the compression that you use. So the data should be compressed. So you restrain the data transfer that you do between your server or your client and the data itself. So this was just a small graphic explaining how to choose maybe the best compression for your use case and for the type of data. So data has to be compressed pretty wisely. And sometimes the higher compression is not the best one because it will also take some more time to uncompress to be analyzed by your server. Okay. Something that I'll tell every time in all my presentation is like the no data part of your data is as much important as the data itself. Like how you represent the no data part is really, 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 really important. And because you don't want the data to be displayed as the data on the left, left. And so this is like, we should see a map underneath the data, but we can't because there is black all around the data, because we forget to put the representation in the metadata of what is the no data part of this data. And so this is pretty annoying, especially when you want to mosaic the data all together, because then you will consider these black values, which is minus 900 and something, as proper data. And then when you mosaic all the data together, it won't be good. So again, how you represent your data is also important to represent how to represent your no data value. And no data value in a cloud optimized dataset can just be a metadata, or what is the no data value. So like it could be 0 or minus 900 and whatever. It could also be an alpha band or internal mask in the data. So if you are creating like cloud optimized dataset, just make sure that you don't forget to specify what is the no data representation inside your data. So yeah, and on the left side, so we forgot to put no data value. On the right side, we put no data value but choose the bad compression scheme. So we put no data value at 0 but use JPEG compression to compress the file. And because JPEG is not a lossless compression, like it will try to compress the 0 data, and it doesn't work. Cloud optimized dataset, again, you are able to read like small part of the data, and because the data is chunk internally, so you have like small parts that are well defined within the dataset, and there is a common theme is like how big should the internal tiles or internal block should be. And this is really complex because the bigger the block is, the biggest like one GET request will transfer data. But the smallest the chunk is, like the more GET requests you will do to access to create your tiles. So this is just an example of like let's say a binary file could be a cloud optimized relative, and like with like a certain amount of like tile size, and like showing like how many GET requests in theory you'll do to generate the blue tiles. So it's really important. Like you can merge the request horizontally in the x-axis, but not in the y-axis. So this is something to keep in mind when you choose the tile size, and also like to minimize and maximize like the number of requests that you will do to your data set when you create those. And so I talked a lot about dynamic tiling and data sets, and I showed just few tools that can be used to either access those data sets or that create those map tiles, and also analyze your data set itself. So at Development Seed, and one of my open source software is called TiTiler. It's a Python library built on top of Raster.io and GDAL that helps just creating map tiles. So like that abstract all this like tile reading, or like a lot of other things, but tile reading on top of the cloud optimized data set. And this TiTiler is also used in a project we call TiTiler, which is a dynamic tiler. that you can use to create to put on top of your data and create like a dynamic tiling service. And TileBench is another tool that we use to really explore the data and see how many GET requests you generate when you create a tile from a specific data set, and just try to make an understanding of how your data is and how it's working in terms of dynamic tiling. And I was showing an example of like how you can mosaics, do dynamic mosaics on top of multiple raster data. And there is a project called TiTiler PG Stack, where you have all your dataset stored as stack metadata in PG Stack, and you can put TiTiler on top of that and create mosaics.